Today we are going to learn about continuous integration testing with Jenkins, a practical guide. We will dive into configuring Jenkins to automate integration tests effectively, providing you with essential skills to maintain code quality in agile development. Welcome to our video on continuous integration testing with Jenkins. In this session, we'll explore the critical concept of continuous integration, C, a practice that plays a pivotal role in agile development. C involves automatically integrating code changes from multiple contributors into a shared repository. It is essential for detecting issues early in the development cycle, ensuring smooth integration of new code. Jenkins, an open-source automation server, is a popular tool for implementing C. Jenkins automates the parts of software development related to building, testing, and deploying, facilitating seamless integration and continuous delivery. Throughout this video, we will guide you through setting up a Jenkins server, creating and configuring Jenkins pipelines, integrating test frameworks, and automating test execution. By the end of this session, you'll have a comprehensive understanding of how to harness Jenkins for maintaining code quality. To kick off our journey into Jenkins, the first step is setting up a Jenkins server for integration testing. Start by downloading Jenkins from the official Jenkins website and follow the installation instructions specific to your operating system. Once installed, launch Jenkins and complete the initial setup wizard. During this process, it's crucial to install the recommended plugins, as they provide essential functionalities out of the box. Next, delve into configuring Jenkins to suit your team's needs. User management is vital, so create user accounts with appropriate permissions to ensure that only authorized personnel can access and modify the Jenkins environment. Additionally, adhere to security best practices by enabling HTTPS for secure data transmission and regularly updating Jenkins and its plugins to protect against vulnerabilities. By the end of this block, you'll have a fully functional Jenkins server ready to automate your C processes.
With your Jenkins server up and running, the next step is creating and configuring Jenkins pipelines. Jenkins pipelines allow you to define your build processes as code, making them reproducible and version controlled. Start by creating a basic pipeline through the Jenkins user interface to understand the flow. Then, transition to pipeline as code using a Jenkins file, which provides greater flexibility and is stored alongside your source code. A pipeline consists of stages, such as build, test, and deploy, and each stage comprises multiple steps that define the specific actions to be executed. It's crucial to configure triggers for your pipelines to automate execution. Common triggers include code commits, scheduled intervals, or manual triggers. By mastering Jenkins pipelines, you'll be equipped to automate and streamline your C processes efficiently.
Integrating test frameworks with Jenkins is a crucial step in ensuring that your C pipeline effectively validates code quality. Popular test frameworks include Junit, TestNG, and Nunit, among others, each suited to different programming languages and environments. In this block, we'll focus on integrating Junit with Jenkins. Begin by adding the Junit plugin to your Jenkins setup, allowing Jenkins to recognize and process Junit test results. Configure Jenkins to generate test reports, which provide valuable insights into the health of your codebase. When a test fails, Jenkins can be configured to notify developers immediately, fostering a culture of continuous feedback and rapid issue resolution. By integrating test frameworks with Jenkins, you ensure that only high-quality code progresses through the development pipeline. Automating test execution upon code commits is a hallmark of effective C practices. To achieve this, set up webhooks in your source code management (SCM) system, such as GitHub or GitLab, to trigger Jenkins builds automatically when code is pushed to the repository. Alternatively, configure Jenkins to pull the SCM at regular intervals, checking for changes and initiating builds as needed. Automating builds on commit ensures immediate feedback on code quality. Additionally, configure Jenkins to test branches and pull requests, allowing you to validate new features and bug fixes before merging them into the main codebase. By automating test execution, you maintain high code quality and facilitate smooth integration, reducing the risk of defects in production.
Once your tests are automated, monitoring and analyzing the results is critical for maintaining code quality. Jenkins provides comprehensive test reports that summarize test execution, highlighting passed, failed, and skipped tests. Access these reports through the Jenkins dashboard to gain insights into the health of your codebase. Analyzing test trends over time helps identify recurring issues and flaky tests that fail intermittently due to external factors. Visualizing build history offers a broader perspective on the stability of your projects, revealing patterns and informing decision-making. Use these insights to improve test coverage, ensuring that your tests adequately exercise the codebase. By effectively monitoring and analyzing test results, you contribute to a robust and resilient C process. Despite thorough planning, integration issues can occur in any C/CD pipeline. Common issues include build failures, pipeline errors, and plugin conflicts. To troubleshoot Jenkins pipelines, begin by examining the console output for error messages and stack traces. Debugging involves identifying the root cause of failures, which could stem from misconfigured scripts, incorrect environment settings, or outdated dependencies. Handling build failures requires a systematic approach, analyzing logs and test reports to pinpoint the issue. Plugin conflicts can disrupt Jenkins functionality, so ensure that all plugins are compatible and up to date. Maintaining environment consistency across development, testing, and production stages is vital to prevent unexpected behavior. By addressing these challenges, you'll optimize your C process and ensure seamless integration. To illustrate the power of Jenkins in a real-world scenario, let's explore a case study of a successful Jenkins implementation.
Company X, a mid-sized software development firm, faced challenges with manual integration processes that led to delays and quality issues.
By transitioning to Jenkins for C, the company automated its build and test processes, significantly reducing integration times. Key challenges included integrating diverse test frameworks and managing legacy systems, which were addressed through strategic plugin selection and custom scripts. The impact was profound: development cycles shortened, code quality improved, and customer satisfaction increased. Lessons learned from this implementation include the importance of continuous monitoring and refining C processes to adapt to evolving project needs. Future enhancements involve scaling Jenkins to accommodate growing project demands and incorporating advanced analytics for predictive insights. This case study demonstrates the transformative potential of Jenkins in streamlining development workflows. In conclusion, mastering Jenkins for continuous integration is a valuable skill in modern software development. Jenkins empowers teams to automate build and test processes, ensuring high-quality code and efficient workflows. Key takeaways from this video include understanding the importance of C and agile development, setting up and configuring Jenkins pipelines, integrating test frameworks, and troubleshooting common issues. We encourage you to implement continuous integration practices in your projects, leveraging Jenkins to enhance productivity and collaboration. Continuous learning and adaptation are essential, as the C landscape evolves rapidly. Thank you for joining us in this practical guide to continuous integration testing with Jenkins. We hope you feel empowered to elevate your development processes and maintain code excellence.